Hey everybody, we're going to get started. Title of the talk is Fix Production Bugs 20 times faster. Who doesn't want to fix bugs faster? But then again, I know this crowd, none of you write any bugs for a start. So John, you're off to a bad start already. John and I had nerded out about structured logging. I'm looking forward to this talk. So without further ado, please welcome John to the stage.
Hi there, I'm here to talk about how to fix production bugs 20 times faster. So, here is a true story. It's based on a true story. Names have been changed to protect the innocent. Stop me if this sounds familiar. Okay, it's Friday afternoon, and I'm on call. I'm crying into my beer as I speak to you. I'm on call, and I get a Slack notification. It's a bit strange. It's from support. Looks like something's going wrong. Okay, and another one. And okay, looks like customers are not getting password reset emails. It's a bit strange. Okay, so let's go to the logs, and we'll just search for... okay. Fine. We'll look in the code, and the code is kind of fine, which doesn't really help me. Meanwhile, the CTO, James Green, not his real name, is getting a bit nervous. And he's alerting the whole channel. This is a real emergency. There's loads of customers that are taking to Twitter and complaining they can't get into their accounts. They're locked out. Okay, so I'm in the middle of something else, but that's okay. I'll drop what I'm doing and I'll pair with a colleague. And we'll look into the background job and we'll add some extra error logging. And while we're waiting for that logging to deploy, it's fixed. That's kind of strange. It's okay. I mean, we'll fix it later, right? It's fixed itself. It won't come back. We'll just add it to the backlog. Here's the backlog. That's the backlog. No, that's the backlog. We'll add it right down there, just at the very end, and that will get done really quickly. But, it's fine, because it's a one-off issue, right? I mean, it won't come back again. It came back again. Groundhog Day, same problem, but that's okay. It's fine, because we added in our errors into the logs, and we'll just search for them. Seriously? Okay, well, there's a background job admin panel, okay? So we'll go into that. Here's what it looks like, and that tells me that's something, some errors, some failures. Okay, that doesn't really help me. So this was the experience that we had at my day job. I worked for a company called Bigger Pockets in the US. And we went round this vicious cycle where developers were continuing looking into logs, not being able to find something. The issue went away, it came back, they would add more logging, and we were just going nowhere with this. And we were wasting a lot of time. So the first thing I think when I come across something like this is, maybe that's just us. So I put out a survey and I asked 50 engineers this question. I'm not going to read it out to you because you're all smart people and you can read. These were the results. So 30% of people lacked visibility into their application's performance or errors every week. And half of them, over half of them actually, found this every single month. So it's not just us. Okay, so that's the data. What about the feelings? Well, as an engineer, I'm not that keen on talking about my feelings, but let's do it anyway. So first of all, I feel really annoyed. Are you serious? It's 2024. We have AI, we have LLMs, we have all this cool stuff, and yet I can't figure out what's gone wrong with my app in production. Okay. Then I'm just a bit bored. I'm kind of going through the logs. I'm not finding anything. I look at the stack trace again. Like, this kind of sucks. And then the pressure kicks in. Maybe it's been 20 minutes, half an hour, maybe even an hour since that outage. And now I have to go to my manager and say, I don't know what's going wrong here. I've been doing this for 15 years. You know, I'm a senior engineer. You're paying me a lot of money, but I can't fix it. And then you start thinking, or at least I start thinking, maybe the problem's me. Maybe I'm just not a very good software engineer. And so if you've ever felt like this, here's the good news. It isn't you, and you're not alone. So here is a 5-step process that I've evolved from my day job in order to fix this problem. And there's really 5 ideas on here. The first thing you do is question. What is the question you want answered? Next, you decide on what data to collect to answer that question. Then you build some instrumentation, you use the graphs, and finally, you improve. And if you put this on its side, it looks like some steps. So I call it the steps to observable software. Okay, so let's walk through this with the example that I gave at the beginning. What's the question that we want to answer? Well, the obvious one is, why are password reset emails not being sent? Now, this is a really vague question. There's not a single graph that I could show you that would answer this question directly. So instead, we have to come up with some hypotheses. This might sound familiar, the scientific method, anyone? Anyway, so we come out with some hypotheses. They might be failing, they might be timing out, or they might be delayed. Well, the first 2 are out because we already have some error monitoring software and we don't see any errors. So maybe they're just delayed. And this would kind of make sense of why it all of a sudden just kind of recovers without us doing anything. So, just to be clear, this is our hypothesis. There's a queue, and we've got these background jobs in the queue. This is what a healthy queue might look like. The green jobs would be our password reset email jobs. And the other ones would be anything else that the system has to do in the background asynchronously. And here is what we think our queue is doing. So we think these jobs are getting pushed down to the bottom and being delayed. So how are we going to answer if this is a problem or not? We can come up with a more specific question. What jobs are taking time within that queue? Now that's a question we can use a graph to solve. So next we come on to what data to collect. I like to think of it as these 4 dimensions. And for those of you who've done any SQL querying, this might sound familiar. Select by, group by, values of. And so the event that we want is the job performed. We want to see what happened when one of these background jobs had finished. We want to filter by the queue of those jobs so that we can just see the data for our 5 minutes queue. We want to group by job class, and we want to plot the values of the duration. This will tell us which jobs from which classes are spending the most time. Okay? Next, we need to build some instrumentation. Now, this is not a technology-specific talk. My background is in Rails, but here are some 3 principles behind this. So the title of the talk has structured logging in it. So I'm pretty much sure that you can all guess whether it's plain text or structured, but I want to talk about why, a few principles to select the logging library, and then finally how we customize it. So we're going to choose structured logs, but why? And what are structured logs anyway? Here's what a plain text log looks like. I'm sure you've all seen this, whether it's Java, C#, JavaScript. There'll be a logger, and it will just pass in, you'll pass in a string with some parameters interpolated in the middle of a string. And it's just a plain old string, nothing to see here. That's that unusual. When it comes to your logs in any of these observability tools, here's what it might look like. So you've got a date and you've got a content field. And so let's say we want to find any mailer jobs in those logs. Here's what we would have to do. Good old regular expressions to the rescue. Anything containing that exact string, okay, cool. How do I now find any of those with a duration of less than 300 milliseconds? That's right, I can't, because the duration is just splurged into that text field, into that string. There's no way of extracting it. So this is useless. And I'm still absolutely amazed at how many people think plain text logs are enough to run a production system on. So here's what a structured log looks like. It looks a lot weirder, but this comes with some really, really powerful benefits. You can see that there is a structured, hence the name, format to that logger statement. And here's what this looks like in your observability tool. You now have columns a little bit, again, like a database. These are not new ideas. We use these in databases all the time, but for some reason, we don't use them that often in logs. So you've got these different columns that you can query on. We can query on a specific job class now. We like this. This is good. Next, the logging library. I've put some example logging libraries up on the screen based on whichever language you're in. Obviously, as I said, my experience is in Ruby, and I can highly recommend Semantic Logger. And thank you to all the open source people out there that maintain these things. It's a thankless job. It's really difficult to make great open source software. So we're very lucky in our ecosystem. Many of these logging libraries or vendor logging libraries will have some degree of automatic logging for you built in. So if you're using a framework like Express or .NET, it'll do some degree of automatic instrumentation for you. And there are lots of extravagant promises made by vendors and open source software maintainers that you just need to drop it in and it all just works. I have never, ever had that experience, and I'd be very open to any of you who have had that experience. But in my experience, there's a few weaknesses and a few missing things. There are a lot more besides this, but I've come across these three things and many, many more. I just want to cover these three weaknesses and what you can do about them. So first of all, there are no conventions. So we talked about the attributes and the values. There are no standards when it comes to these attribute names. Anybody can choose any of these names. One person in one team can choose one set of naming conventions, another in another, and then nobody can query each other's logs, which is not what we want. So to solve for that, we use something called OpenTelemetry. It's quite well known now. It's been going for about 7 years. It's a CNCF open source foundation project. It's growing at an enormous rate, and it's also moving at a very fast pace. So what I will show you today will be out of date in 6 months. But c'est la vie. So OpenTelemetry has a bunch of semantic conventions about how we can name these attributes, and they're really helpful for many different reasons. So here's what we want to instrument our job queue name. And this right here is the official OpenTelemetry standard. If you go to that link at the bottom, go.joyfulprogramming.com/otel-msg, that will show you all the semantic conventions. So as a reminder, this is what it might look like with automatic logging, and this is what it might look like once you converted that automatic logging to standardized OTel conventions. You can see the name spacing here, and come and speak to me afterwards if you don't understand why the name spacing is important. Second of all, we'll talk about missing attributes. To my absolute amazement, many automatic logging tools don't even record these things on the slide. And I've heard the arguments about, it's like I got PII and we'll filter out the PII before it gets to the logs, but don't just switch them off. I don't understand how anybody can understand their system without this stuff. This is like absolutely critical, and there's a whole bunch more besides. Third of all, missing API requests. For this, I would use something like middleware. So you can have middleware that sits before your API adapter, before your HTTP client goes out to the network and logs both the request and the response coming back in. And that is incredibly useful. Here's what it might look like. So you can see here under HTTP, you've got http.request.response. And so you get the headers, the methods, the status codes, and the URL of that entire API request. So that's really useful as well. So very brief. The next thing we need to do is send it to our tool. And this is where I talk about how to pick a tool, which is an entire talk unto itself. There are many, many of these tools. You may have heard some of these: Datadog, New Relic, Honeycomb. You've probably used one or many of these. Sentry is another one. And the three principles that I would always come back to when choosing one of these tools, number one is cost, hands down. There are some of these that are incredibly and ruinously expensive. And the second problem is related. If you're locked into that vendor, if they're too high in terms of cost, you have no option but to be locked into them. So this is also an advantage of OTel. OTel allows you to instrument your app in a standard way so that you can actually switch from one solution to another. And finally, usability. It's important that it's usable. Let's use these graphs now, speaking of usability. So as a reminder, here are our 4 attributes. Okay, so we have our nice logs. They're all queried using this, you can all query them using these nice transformations. And so we're going to search for the job queue within 5 minutes. There we go, instantly. We've got all the logs pertaining to that. Now we're going to search for jobs performed in that queue. Just as some context, we've also got events called job.enqueued, job.scheduledAt. So these are just the jobs that have been performed. And finally, we're going to group it by job class. And we get a nice little graph with these blue bars, all color-coded. This is pretty cool. And once you start using this, you never really want to go back. Lastly, we're going to improve. So I'm a bit of a perfectionist. I would criticize my own work quite regularly. And you can go back to any stage of the process. It might be you look at the logs in your observability tool and you realize, oh, there's this attribute, I've misnamed it, I've not quite got it right. Or you might say there's this other attribute that actually now I see the logs, I want that. I want that extra thing. So you can go around that loop of building and deploying and using a few times. And once you think you're happy with it, you can show your colleagues. And that's what I did at Bigger Pockets. And that's why we have what I would refer to as a culture of observability. Because what happens is you start with your own tiny little area, you deploy one tiny little change to production, and you get that working. And then you show your colleague. And what generally happens, or at least it's happened with me, that colleague then says, fine, that's pretty cool. I don't care about that, John. I don't care about background jobs. But I would love to know the speed of our test suite. And you say, cool, well, let's do it together then. And they get to see the speed of the test suite. And then their team see what they are doing with the speed of the test suite. And so it kind of spreads around the company. And people start to get this idea of what's possible if we start to break open the black box and understand what's going on inside. And so as an example, right now, we might want to add job latency, which is the time from when the job is enqueued to the time when the job is picked up by the worker. We might want to add request ID or IP. So now I just want to show you kind of the end result of this. We went around this cycle many times at Bigger Pockets, and here is what our incident now looks like. It's Friday. I'm still on call. Never mind. But it's now Friday morning, and I get a notification. Kind of same deal as before, except this is from our monitoring software. And it's telling me something is a bit strange here. Okay? So I click on the link in that message, and here's what I see. Holy cow, look at that blue line. That doesn't look right. What is that? Oh, it's the within 5 minutes queue. It's reaching 15 minutes latency. Okay, let's have a look at that then. So the question I would have is, so which jobs are taking the most time then? We're going to search by jobs performed. Within that queue, we're going to group by job class, and we're going to show the sum of duration. And this is what we see. Okay, that blue bar looks very suspicious. It kind of correlates to the other graph that we saw before. What is that? Wow, okay, that's the update user visits job. I've never heard of that before. What on earth is it? I wonder what's enqueuing that job. Okay, let's ask that question then. Let's look at jobs enqueued. Within that queue, grouped by HTTP resource. Now this is a new field, and it concatenates the name of the controller and the action. I'm going to show all logs. Wow, look at that green bar. That's interesting. What's that? It's the profiles controller, and it's the show action. So something's hitting that show action in the profiles controller. That's interesting. What's IP is hitting that action? Let's do it again. Requests handled by that controller, and we want to group by IP address. That's a pretty definitive answer. It's that IP. So here is our actual root cause. There's clearly a scraper at that IP address. It's hitting the profile show, it's flooding the queue with analytics jobs, and it's delaying the password reset emails. And so we're now like 6 minutes into the incident, maybe. And the fix is pretty clear. We block the IP in our infrastructure, and the super cool thing is now we can check, is it fixed? Oh yeah, it is, I see. Gone back down to normal. That is it. No customer impact, no manager breathing down our necks, no CTO getting annoyed. This feels absolutely incredible as an engineer. And you can go really fast with this. You can actually debug things so much faster. And finally, it gets really, really addictive. Once you've gone round this cycle a few times and you start realizing, hang on, I can ask any question of my logs. You start to ask questions that you weren't even curious about before. You might go into a graph and think, as I did recently, why have we got a flood of 404s coming into the site? Or why does our traffic spike on a Wednesday at 3 a.m.? That's really weird. Oh, the majority of those are iOS users. Oh, hang on, has somebody deployed something to the App Store without us knowing? So here are some of the results we've got from this process. We've reduced our downtime by 98% over an 18-month period. We've reduced our errors by 83%. And finally, we can fix bugs 20 times faster. So here is a link tree. Here's a QR code. Scan it. I've got a bunch of free resources there. There's a cheat sheet for structured logging, a cheat sheet for structured errors, which is another concept I've not talked about here. And I'm also offering 2 hours of free consulting to anybody who's interested in taking this further. If you or your team has hit any of these kind of issues and are interested in talking more, please get in touch. Thank you for your time and attention. My name's John Gallagher. I have my own company, Joyful Programming, and I work for Bigger Pockets. What are your questions?
Any questions for John?
Thank you for the talk. What are the trade-offs associated with this? What are the downsides?
Great question. I love it. Normally when I'm proposing something, I talk about the downsides first, just so that nobody's thinking this is a panacea. Number one, it takes a lot of work and a lot of energy and a lot of learning, which is partly why I'm so passionate about helping other people to do this. I faced a learning curve. I mean, I've been an engineer for 15 years, so I've learned a lot of things. But the learning curve on this was like a cliff. I found, again, as I've said, dropping in a library and it all just works, that's the promise. And I have faith that in 20 years we'll get there, but we're a long way off that. So the hardest bit is instrumenting the app. And actually, really, the hardest bit is converting it from this massive project, let's improve observability, which, as we all know, would never get done, into something that you can granularly approach every single day. So this is what I'm trying to help people with, is break this huge problem down into what can you do today, next week, next month, just to get your foot in the door and start doing a little bit of this. But OTel is really hard to get your head around. It's very, very complicated. Instrumentation, logging, tracing, metrics, there is a whole load in here. So if you're interested in doing it in your company, talk to me afterwards. I'm here to help and try and make all of this insane complexity much, much simpler. But it's a great question. There's a lot of drawbacks. It takes a long time and a lot of effort, basically.
Thank you.
Thank you.
Hi. You talked about how the cost of the tool is very important. From your screenshots, I think you were using Datadog there. How do you, so I think you may see where I'm going there. How do you balance things like, for example, the amount of data that you tag that is queryable, which is very expensive in Datadog if you're not careful, with what you leave in and what you leave out in order to make the costs bearable?
Great question. There is no one easy to answer to that. I've had that question many times before. If it was easy, I wouldn't really be up here and everybody would be spending like $200 a month on Datadog, and wouldn't that be amazing? We do use Datadog at work. I deliberately tried to make those graphs tool agnostic. Clearly didn't do a very good job because you could see it was Datadog. In answer to your question, I took a day and a half and I reduced our logging costs by 41%, which was a 5-figure sum for our company. So there is a lot of noise that gets logged, and you can use logging filters to reduce that noise. That's tactic number 1. Tactic number 2, which is not great, is sampling. So I would never suggest sampling logs, but if you absolutely have to, then you have to. But what's critical is that you use tail sampling, not head sampling. For goodness sake, don't use... So the difference between head and tail sampling is, head is just, we're going to sample 5% of everything. 5% of errors, 5% of infos, 5% of everything. And so, 95% of everything goes to the bin. And so good luck, debugging your next production issue, because you've got a 95% chance it won't be there in the logs. How is that useful to anybody? It isn't. So instead, there's this principle called tail sampling, that after the details have all been gathered and before it's about to get sent to the observability tool, it does some rule checking. So it can say, keep 100% of your 500 errors, but drop 30%, 80% of your 200 errors because we're less interested in errors, 200 responses because we're less interested in those. That comes with its own trade-offs because you can't understand what the customer has done. The third option is to reduce your retention period. That's an obvious thing to do, but I don't like doing that. That's kind of a method of last resort. So reduce the noise, tail sampling, and ultimately I think option 4 is get OpenTelemetry in there and switch away to a different provider that's cheaper. It's easier said than done. I've spoken to a few people at this conference that's trying to migrate to OTel, and it's easy to say, and it's really, really difficult to do. The OTel tools are still fairly immature, but in 5 years, they'll be absolutely rock solid, I have no doubt. Any other questions? I'm at time. I bet I am.
I think that's everything. Thanks very much, John.
Great, thank you.